All right. Hopefully most of you have turned in your homework at this point. If you haven't yet, make sure you do that before the end of class. But please don't be working on it right now because this is our 1 day of graphing. Unlike some of the other units where there's been multiple days of graphing, only got one here. The graphing is very much a pattern, and I need to make sure that we've got that pattern down. Okay then. So looking at the notes for section 4, we're going to go over how to graph logarithms. And the key thing that you need to realize is that, again, logarithms are the inverse of exponents. So if you know the points for an exponential graph, you know the points for a log graph. It's up there on the board. I'm going to write it right here as well. If you want to add it into your notes, this way anyone that's watching later on can see as well. If I was trying to graph y equals 2 to the x power, I could put in any numbers that I want for x, but if I put in big numbers, they're going to go off the graph. So I'm going to put in 0 and 1 and 2 and 3. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. Is everybody good with those? Just the powers of 2. And if I were to graph that, my graph would kind of look like this. Be kind of going long flat along the x-axis and then accelerating up once we got into the positive numbers. So then if I want to graph y is equal to log base 2 of x, it's the same numbers, but the x's and y's are switched. So if I put in 1 for x, I get 0 for y. If I put in 2 for x, I get out 1 for y. If I put in 4 for x, get out 2. Put in 8, I get out 3. The exact same numbers, but the x's and y's are switched because, again, log is the inverse of an exponent, which means inverse means x's and y's are switched. So my graph is actually going to look similar to that, but it's going to go more like this. It's going to be flipped across the line y equals x. So let's actually try this. Now, I already made the table up here. I'm going to copy it down here so it's all in the same place for your notes. So same exact table that I just wrote before. X and y. If I put in 1 for x, I get out 0. Put in 2 for x, I get out 1. Put in 4 for x, get out 2. Put in 8 for x, get out 3. Again, these are the powers of x plugged into the log function. Log base 2 of 4. 2 to what power makes 4? The y value is 2, the exponent. So now if I graph those, 1, 0, 2, 1, 4, 2, 8, 3. Now, what about the rest of the graph? Some key things to remember. First, I cannot put negatives in for x, because if I'm saying 2 to what power makes this, 2 to what power makes -4? It doesn't work. 2 will never be -4, no matter what I raise it to. So we're actually going to have an asymptote right here at 0. I am not going to cross that asymptote, and I'm actually not going to have anything on the other side of it. My entire graph is going to exist on the right-hand side of that asymptote. Yes. Every problem is going to have a vertical asymptote that you will not go to the left of. If you go on to advanced math, you may flip these around and have them going the other way. But for this class, they're all going to go to the right. Now, what about right here between my asymptote and my first point? What's happening there? If I put in 1/2, so 1/2 for x, 2 to what power gives me 1/2? The -1 power gives me 1/2. What about 1/4? Log base 2 of 1/4 would be a -2 exponent. So my Y values start going down. I get negatives as I put in smaller and smaller and smaller fractions that are powers of 2. So my graph looks like this. It's going to go right along. Let's use a different color to make it real obvious here. Right along the asymptote, coming up, hitting those points, and then kind of accelerating off to the right. Does that make sense to everybody? No, it's Monday. Are we okay? Up and down is yes, side to side is no. We're good with where that graph came from. Yes. Go ahead. Because as long as you understand where that came from, you'll be okay if you miss a couple more examples. But for the rest of us, real quick, I'm going to show you what happens when we change the base. So if I want to do log base 3 of x instead of log base 2 of x. So this was the red graph. Let's make a blue one. So if I do log base 3, same thing, make ourselves a little XY chart with the powers of 3. I can do 1, 0, because 3 to the 0 power is 1. I can do 3, 1, because 3 to the first power is 3. I can do 9, 2, because 3 to the second power is 9. And that's pretty much it. Like, that's all that fits on my graph. So when I graph those, 1, 0, 3, 1, 9, 2 is actually just off my graph. Technically, if I put in 1/3 and get -1, it'd be just to the left of the other point. Not terribly important, but if you needed to check that, needed to be a little bit more precise, you could put in those fractions and get out negative answers. So now my graph's going to be right next to the same asymptote, coming up, hitting those points, and accelerating off to the right there. Should have hit that point right there. Now this next one, you can add in if you want to, but it kind of makes our graph rather busy. There's a lot that fits in here than if we do log base 4. So if I do that one, use lime green here, log base 4. So I'd put in 1, 0. Then if I put in 4, I'd get out 1. If I put in 16, I'd get out 2. This one, I only fit 2 whole number points on there. The 16, 2 is going to be way off my graph already. So if I graph those 1, 0. So everybody's seeing that I'm always going to have that 1, 0 point, because anything to the 0 power is 1. Doesn't matter. That's going to be kind of our anchor point that we're going to have every time. And then from there, 4, 1, and then 16, 2, way off my graph. So again, same general shape, coming up, through, and again, just accelerating off to the right. The last one is this natural log. Okay, I haven't announced this to everybody yet. For the test, you will be allowed to use a scientific calculator. And for this week and on, you may want to have one here in class. You can use your phone right now, but you can't use it on the test. So it'd be best to start practicing using a scientific calculator. I know some of you already have one. Feel free to get it out. If you got one at home, feel free to start bringing it. I have about 20 of them back there, 24. So not quite enough for everybody in class, but hopefully we have enough with the ones of you that have a calculator. If you take one of the ones from back there, please put something back there to remind you to go get it. Put an ID card, a phone, a wallet, something. Put something back there before you grab one so that you remember to put it back at the end of class. Does that make sense? So the reason I mentioned that here is because if you don't remember the base of natural log, hopefully again, natural log means base E. All scientific calculators will have an E key on them. So if you're not sure what E is, find that key. It's usually connected to the natural log key. So most of you, you're going to see the natural log key, and then above it, it'll have a little E. You'll hit shift that button, and it will give you E to a power. And if you put in 1, you should, anybody that has a scientific calculator, go ahead and try it. So try to get E to the first power, get it to give you an answer. And it should tell you that that's 2.71 going on forever. All that we, okay, can anybody not find their E key on their calculator? Find natural log first. So yours is going to be on the right-hand side. I think these are, oh, sorry. Natural log, so second. E to the power. Great. Okay, one up. Yeah, so right on the natural log, keep element right there. So the second yours, okay, clear it, you got natural log together, but that E was going up. So you shift to the natural log and just go to 1, and then enter, and it'll give you 2.7. So if you wanted to use it on yours, clear it. Clear it and put okay. Everybody, if you're using an iPhone, the way it works, you turn it sideways, it'll bring up a bunch of extra keys. You'll find the E key, but it does E of whatever's on screen. So put the 1 in first and then hit E to the power, and it will tell you what E to the power is, E to the first power. So again, if you're using an iPhone, push 1 first, then hit E. It'll tell you E to the first power is 2.7. So the reason I bring that up right here, let's choose a different color, is if I'm graphing this, I'm still going to have 1, 0, but then my first value is going to be E to the first power 1. E to the first power we just found was 2.71. And then if I do E to the second power, I'm going to get out 2. But E to the second power is like 7.39, I think. Confirm that. Try it on your calculator. E to the second power should be about 7.389, something like that. So then when I graph these, this one is going to be in between my graphs of E to the second power, or sorry, of log base 2 and log base 3, because the base is between 2 and 3. So when I graph this, I'm still starting at 1, 0, but now I'm going to have 2.71, so kind of here between my red and purple graph, or red and blue graphs, and I'm going to have 7.3, 1, 2, 3, 4, 5, 6, 7, really like 7.4. See how my blue graph is too high right there? My blue graph should have been just a little lower, so I hit this point because my pink graph should have been above it. So it would be in between the red and the blue graphs. So now my graph comes up, hits those, kind of stays in between the blue and red graphs. Is everybody okay with finding those graphs? Because everything we do today is going to be based on that. The way I'm going to teach you to graph, there's many ways that you could do this. I'm going to show you finding the parent graph and then shifting it. Just move it around. So the first move that we're going to talk about is what if it's negative out in front? Because this is going to be the most common change we're going to have. What if I want y equals the negative log base 2 of x? If I want y equals the negative log base 2 of x, it's going to be the exact same values as log base 2 of x, but my y values are going to be negative. So if I put in 1, I get out 0. If I put in 2, I get out -1. Put in 4, I get out -2. Put in 8, I get out -3. Because again, it just does log base 2 of my number, and then I take my answer and I get a negative from that. So when I come down here and I graph that, 1, 0, 2, -1, 4, -2, 8, -3. Does that make sense to everybody? My asymptote, if I take a vertical line and flip it upside down, does it change? Not really, it's still in the same spot. So my asymptote is going to stay right here. I'm still not going to have any numbers to the left of that. I'm going to graph this down, hit those points, and curve over. So again, pretty much the same graph, but shifted or flipped upside down. And so if I graph y equals negative log base 3 of x, put in my x values and get out y's, I'd have the same 1, 0, 3, 1, negative 1 now, and 9, negative 2. So coming down here, same point there, but now 3, negative 1, 9, negative 2. Make my sketch. Is everybody good there? Does anybody feel like they really need to see C or D on that one? Or is everybody capable of flipping their graphs upside down? So with that in mind, why don't you all go ahead and do number 1 on your homework? I already did it for you, but let's make sure everybody can do that one. Give you like 2 minutes, and you can ask myself or Emily. We'll just kind of walk around, make sure we don't see any big problems with everybody graphing y equals log base 3 of x. Literally 2 minutes here. Let's knock this one out real fast. So walking around, I think I saw just about everybody with the points that we already talked about. 1, 0, 3, 1, 9, 2. Now, places where I will take off points. If I don't see any actual points on your graph, I will take off points. If your graph goes across the asymptote, which in this case is the y-axis, you'll lose points. Now, some of you are asking, okay, well, what about the next couple graphs where there's shifting? So the formula we're going to be using for this is y is equal to a log base b of x minus h plus k, with h and k doing exactly what they've done every single unit of this course. H shifting us left and right, k shifting us up and down. So what I'm going to have you do for most of these is graph the original points for the parent graph and then shift it. So looking at number 1, ignore any h and k to begin with. Just graph log base 2 of x. So log base 2 of x would be, yes, right there. Log base 2 of x, we'd have 1, 0, 2, 1, 4, 2, 8, 3. Get those points down. Then we need to decide, is that plus 4 an h or a k? Is it in parentheses? If it's not in parentheses, it's not h. Does that make sense to everybody? If they want it to be inside log, they would put it in parentheses. So this is a k value. It's going to shift everything up 4. So I'm going to take my whole graph and just move all those points up 1, 2, 3, 4. Up 1, 2, 3, 4. Up 1, 2, 3, 4. I'm off my graph. My asymptote moved up 4, still a vertical line at 0, doesn't change. So my graph here is going to go right next to the asymptote, up along that x-axis until I get close, and then curve across. There is my graph. But now I've got questions to answer along with that. The very first one is the x-intercept. Does this graph have an x-intercept? Yes. These points right here, those are the powers of 2. So 2 to the 0 power would be 1, or 1, 0. It's literally these points right here. that we got, if you want to think of it this way first, 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, and then flip them. So log base 2 of 1 is 0, log base 2 of 2 is 1, log base 2 of 4 is 2. Does that make sense? Those are the points I graphed to begin with, and I just moved them all up. So I have an x-intercept. Does everybody see that it crosses the x-axis somewhere right in here? The problem is, I don't know where that is yet. So we're going to find it by making ourselves an equation, making y 0. If I want to find the x-intercept, y has to be 0. 0 equals log base 2 of x plus 4. So I'm going to take this and solve for x. That means subtracting 4 from both sides. Negative 4 equals log base 2 of x. And then I'm going to use this pattern, the switch from log to exponent. I'll write it up here on screen, and then I'm going to erase it though. So the idea is if I have log base b of x equals a, I can rewrite that with my base coming down to the a power equals x. That's what I'm going to do right now. This pattern, we're going to use this more and more and more to solve these. So in this case, the 2 comes down, 2 to the negative 4 power, what I was equal to comes across as my exponent, and then whatever was inside my log is now what I'm equal to. X is 2 to the negative 4th power. That's my x-intercept, or 1/16. So you can write this either way. Again, this year I'm going to be lenient, flexible with the answers. If you put either 2 to the negative 4th power or 1/16, either of those is acceptable. Yes. So remember that points don't use the bracket or parenthesis. It's just always parentheses for a point because we have that point. You'll see in just a moment when we use domain and range, we'll talk about that, but there's actually not going to be any brackets on this. So does anyone have questions about finding the x-intercept? Does this graph have a y-intercept? My asymptote's on the y-axis. I can't cross that. So I have no y-intercept. On your homework, on the test, it's probably 50-50. Half of them are going to have y-intercepts and half of them are not. It may even be less than that. It may be more than half don't have y-intercepts. Less than half do. Because in order to have a y-intercept, I need to shift the graph left. So no y-intercept. The domain is going to be your vertical asymptote to infinity. So in this case, the vertical asymptote is x equals 0. That means my domain is 0 to infinity. Those two are always going to link. The asymptote is the start of your domain. So our domain goes from 0 to infinity. And now, easiest question on the whole test, because I'm going to tell you the answer right now. If they ask you for any ranges, it's all real numbers. Negative infinity to infinity. All real numbers. Because these graphs always go all the way down to negative infinity, all the way up to positive infinity. You could fill in every single range on the homework right now because they're all the same. Does anyone have questions on that one? So why don't we try number 2 on the homework right now? Oh, no, we're going to wait on that one. That's a natural log. Let's do one more example. Then we'll come back to that. Everybody look at number 2. Negative natural log of x minus 3. So this one, again, that minus 3 is a k value. It's going to shift us down 3. Natural log of x. Natural log of x means log base e. So my starting points are going to be 1, 0, 2.71, and 7.4 roughly. except, okay, I put those down. You don't even have to start with those. You could start with them flipped upside down, right? This is negative the natural log. So I'm going to actually erase those two and put them as negatives. 2.7 negative 1 and 7.3 negative 2. Does that make sense to everybody? If you forget what E is, use your calculator. Just do E to the first power, E to the second power. Get those answers. Then shift down 3. So I'm going to take each of these points and shift it down 3. Down 3. Down 3. Down 3. If you don't like to show those original points, you could erase them if you wanted to, but they also help me see what your work was, what you did in order to get your points. My asymptote's still in the same place, so I'm going to draw the upside down graph here, coming down, hitting those points. That was not great. Let me try that again. Even that is getting too far away from the x-axis too fast. That's a little better. Any questions on that one for the graph? So you took those 3 points of the natural log, flipped it upside down, shifted it all down 3. Let's find the x-intercept. The x-intercept, put 0 in for y. 0 equals the negative natural log of x minus 3. I'm going to add 3 to both sides. 3 is equal to the negative natural log of x. But the natural log is log base e, so negative log base e of x equals 3. Let's get rid of that negative by multiplying both sides by -1 or dividing both sides by -1. So -3 equals log base e of x. And then I can just rewrite it. X is equal to e to the -3rd power. Right? Base comes down. Whatever I was equal to is my exponent. Whatever was inside the log is what I'm equal to. X equals e to the -3rd power. That's my x-intercept right there. It's going to be a decimal. You could try it. You could raise e to the -3rd power. Let's just see real fast. That would get me. Ooh, does this calculator care about a negative? 0.0497. So like 0.05. It should be like right next to the x-axis. So the x-intercept is e to the -3rd, comma 0. This one, once again, does not have a y-intercept. So the y-intercept would be none. Again, my domain and vertical asymptote haven't changed. 0 to infinity. We did have someone ask last period, why does the 0 on my domain not get a bracket? Remember, if that's an asymptote, I never actually get to it. Does that make sense to everybody? I will never, if you try to put the log or natural log of 0 into your calculator, it will give you an error. There is no log of 0. So again, no bracket there because we don't have any points on the actual 0 value. Range, though, is the same as it always is, -∞ to infinity. Go ahead and do number 2 on the homework and answer. You can answer the questions for 1 and 2 at this point. I'll give you 3 or 4 minutes. Let's do 4 minutes to try to finish up questions 1 and 2. And again, I'll come around and answer questions. family. What? Now, just a heads up, if you have a graphing calculator or you use Desmos, you can easily check your answers for this. But please make sure you can do it on your own, because notice I said on the test you can use a scientific calculator, not a graphing calculator. Scientific is fine. Anything that you can have multiple lines, you can do multiple steps, that's all good. But no graphing calculators on the test. All right. I'm going to do one more example for you, and then we're going to do one on the homework together, and then you're going to have whatever remains in class to work on the homework. Okay. So turn to the back page. Actually, should I do two? I think, is everybody good with the idea, the concept of H shifting us left and right? Do we need an example of just H, or can I go ahead and just add H to K and do both at the same time? If we have any issues, please ask. But let's go ahead and look at number 7 on the back page. Not the one above it, not number 3. Apparently my numbering was off. I got rid of some of the examples, and we're still going to get rid of even more of the examples. We're just going to do number 7 here. So this one, log base 3 of x minus 3 minus 1. So x minus 3, that minus 3 is going to shift us right 3. The minus 1 is going to shift us down 1. Does that make sense to everybody? So I'm going to take my graph of log base 3, which has the points 1, 0, 3, 1, and 9, 2. You guys focus. We're putting it all together now. We're going to take those points and we're going to shift them all right 3 down 1. So right 3, 1, 2, 3 down 1. Right 1, 2, 3 down 1. And this one's way off over here. 1, 2, 3 down 1. If I wanted to be precise, when I'm that far off, I might want to actually label that point and say, okay, it was 9, 2. So 9, 10, 11, 12 shifted right 3. And then it was 9, 2 down 1. So that point's 12, 1. Way off the graph. But there's a reason I'm keeping it there. My asymptote goes from being 0, also shifted then right 3. So I'm going to draw in that asymptote at 3. I have no points to the left of that. So my actual graph then starts down here, comes up, roughly like that. Is everybody good with just the shifting? Starting with the same points, shift right 3, down 1. There's our graph. Now we can answer these questions. The x-intercept. Does everybody see that I already have the x-intercept? I don't have to go solve for it because I've already got it on my graph. 1, 2, 3, 4, 5, 6. My x-intercept is 6, 0. This one, once again, I have no y-intercept. So none. My domain and vertical asymptote now, the vertical asymptote is at x equals 3. So my domain is 3 to infinity. Everything from that asymptote to the right, the range is still negative infinity to infinity. So then the average rate of change, this showed up on our practice test last week, and some of us had forgotten how to do it. So the average rate of change is the change in y's over the change in x's. If you want a formula, the slope formula is y2 minus y1 divided by x2 minus x1. That's the rate of change slope formula. So it wants the rate of change from 4 to 12. This is why I kept that point that was off the graph, because that's where I'm ending. I'm going from 4 right here, up and over to 12 over here. So I can either use the formula, use some different colors here. 1 over 12 minus 4 over negative 1 would be this point over here. 4, negative 1. So minus negative 1 minus 4. 1 minus negative 1 would be 2. 12 minus 4 would be 8. So 2 over 8, or if I can see the points, just count up 1, 2 over 1, 2, 3, 4, 5, 6, 7, 8. I have to be careful when you're counting off the graph. Does that make sense? But it should be 2 over 8. 2 over 8 would be my rate of change, which would reduce to 1 over 4. Okay, everybody look in the homework now. Everybody turn in the homework. Look on the second page at that number 7. We'll do this one, and then whatever time's left, you can spend working on the homework. So number 7, they're trying to trick you with this one. We've seen this happen a couple times in different units. This 2 is a k value. Move it. Rewrite this as the negative log base 2 of x plus 1 plus 2. That 2 is positive. It should go on the end. The negative is in front of the log. It stays there as essentially your a value. So now when I graph this, log base 2, so I'm going to have 1, 0. And then I should have 2, 1, but the negative is going to make it 2, negative 1, 4, negative 2, 8, negative 3. And then shift all those points left 1 up 2. 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 And left 1 up 2. The asymptote also gets shifted left 1 up 2, but the up 2 doesn't really do anything to it because it's a vertical line. So there's my asymptote shifted left 1, which is why I finally have a y-intercept. Yep. Finally have a y-intercept there. Get to answer something beyond just none. This one's really nice. I have an x-intercept at 1, 2, 3. I don't have to do any work. My x-intercept is 3, 0. My y-intercept is 2, 0, or sorry, 0, 2. If you didn't have it on there, if it wasn't a nice point, you can plug in 0 for x like we did last week. Remember, we actually found y-intercepts last week. We found 3 of them on the homework by just plugging in 0 for x and simplifying. The domain and the vertical asymptote. Vertical asymptote is x equals negative 1. So my domain is negative 1 to infinity. My range is still negative infinity to positive infinity. And then it wants the average rate of change from 1 to 7. So from 1 to 7, here's 1, here's 7. Looks like I'm going down 1, 2, over 1, 2, 3, 4, 5, 6. Down 2 over 6 if you just count on the graph, or you can do change in y's over change in x's. Either way, you'll get negative 2 over 6 or negative 1/3. Does that make sense to everybody? I know it's Monday, we're still waking up, although it's already almost 11 o'clock. Hopefully we're good to go. Let's get as much done as you can. You've got about 8 minutes here. Knock out another problem or two. So hopefully you're not taking home more than 10 or 15 minutes of homework tonight. Okay. And again, Emily and I will walk around and answer any questions you have.